All right, today we are pulling back the curtain on something most of us have gone through but probably never really thought about. We're diving into the hidden, high-tech world of robotics that kicks into gear the second after your blood is drawn.
You know the drill, right? A little pinch, a tube fills up with blood, and then a nurse whisks it away. But that is just the start of this incredible, high-speed journey. So where does that little vial actually go? Well, let's follow it and find out.
So, this first part of the journey is what the experts call the pre-analytical phase. This is where your sample starts its big automated adventure. And honestly, it's where some of the most critical steps happen to make sure your results are, well, your results. Yeah, accuracy starts from the absolute first second. To make sure there are zero mix-ups, modern labs use these automatic tube labelers that print and stick on a unique barcode. Think of that barcode as your sample's passport for its entire trip. It's how it gets tracked with insane precision. And get this, automation is even pushing into the moment of collection itself. There are now robotic phlebotomists that use infrared light to map out your veins, then use ultrasound to check the blood flow before a robotic arm makes a perfect insertion. It sounds like something straight out of a sci-fi movie, but it's real, and it's all about making the process faster and more accurate for everyone. Now, to really appreciate how brilliant modern labs are, we've got to take a quick look back at how this whole thing started. The very first automated systems were, well, they were a lot like a factory assembly line. Okay, so check this out. This is a diagram of an early continuous flow analyzer. In this thing, all the samples and all the chemicals flowed through one single continuous tube. And the only thing separating your sample from the person's before you? A tiny little bubble of air. I'm not kidding. A really easy way to picture it is like a train on a single track. Every single sample got the exact same set of tests in the exact same order. There was absolutely no flexibility. It was a huge deal for its time, for sure, but man, was it rigid. So, as you can imagine, that old assembly line model is pretty much gone now. The modern lab runs on a completely different philosophy, one that brings a level of speed and flexibility that the early pioneers could only have dreamed about. And this chart just shows the leap perfectly. Instead of one long stream, modern analyzers are discrete, which just means they handle each sample separately, in its own little container. This is a game changer, because the machine can run a totally different panel of tests on your sample versus the one right before or after it. It's no longer a one-size-fits-all situation.
So what do one of these modern marvels actually look like on the inside? Let's take a virtual tour inside a super common automated analyzer, the Beckman Coulter AU480, and see how all this stuff really works.
It all begins here. Your sample tube, with that all-important barcode, gets placed in a rack on this tray. The second it's loaded, a scanner zips past, reads the barcode, and tells the machine's brain exactly who you are and what tests your doctor ordered. Then this guy swings into action. This is the robotic sampling probe. It zips over to your tube and sips up or aspirates the exact tiny amount of blood it needs for the first test. And we are talking about just a few microliters here. That's millions of a liter. The precision is just incredible. Now, at the very same time, the machine is getting the other part of the recipe ready. This big refrigerated carousel holds dozens of different reagents. Those are just the specific chemicals designed to react with your blood to give a result. And keeping them chilled just ensures they work perfectly every single time. So the sample and the reagent both get put into this tiny little reaction cup called a cuvette. Deep inside the machine's core, you've got robotic arms mixing them together, and then a photometer, which is just a fancy device that measures light, shines a beam through the mixture to analyze the chemical reaction. This is where the magic happens and all the raw data gets created.
Okay, so the physical work is done. The chemistry has happened, but your sample's journey isn't quite over. Now we're in the post-analytical phase, which is all about turning that raw data into a result your doctor can actually read and use.
So, first, the machine's onboard computer crunches all the numbers from the photometer and calculates a final result. Then, that data gets beamed over to the lab's main computer system, where a trained medical technologist reviews it. And finally, your original sample tube is automatically capped and stored away, just in case they need to run a retest.
So we've seen this unbelievably complex dance of robots and chemistry going on inside this box. But why does any of this matter? What's the actual real-world impact of this whole automated revolution?
Well, the benefits are just enormous. These machines can process hundreds, sometimes thousands of samples an hour, which massively cuts down on the chance for human error. They use tiny amounts of your blood in the reagents, which saves waste and money. But the most important benefit of all? It's getting accurate results back to your doctor and back to you
way faster than ever before.
I mean, this level of automation has totally changed the game in diagnostics. It really makes you wonder, if we can build a tiny automated factory inside a box to analyze blood, what part of medicine is next? What routine procedure that we do today is going to be completely unrecognizable in another 10 years? Definitely something to think about.